Yes. Good evening to all. On behalf of the Department of Electronics and Telecommunication Engineering of Jawahar Education Societies, AC Patil College of Engineering, and the entire organizing committee of Atal FDP, I, Mr. Sanjay A. Patil, extends a very warm and heartfelt welcome to our resource person, Mr. Ankit Kumar, and all faculty participants, research scholars, and my dear colleagues to the day third, session 6 of the AICT Atal sponsored 6-day online faculty development program. I welcome today's respected speaker, Mr. Ankit Kumar. Ankit Kumar holds a bachelor degree in electrical engineering from Savitribai Phule Pune University, Pune, and master's degree in control system from Savitribai Phule Pune University, Pune. Presently, Mr. Ankit Kumar works as an application. Hello. Presently, Mr. Ankit Kumar works as an application engineer for Mathswork at Design Tech Systems Private Limited, Pune. In this capacity, he works with academic institutions to effectively use Mathswork resources in the research and education. His area of expertise includes model-based design, simulation, and electric vehicle. He has over 11 years of experience working as an academic researcher and assistant professor. He has published over 5 conference papers. Thank you, sir, for joining us. Before I invite Mr. Ankit Kumar to start his session, couple of instructions to all participants. All are requested to keep their microphone mute during the session time. There will be a 10 minutes question answer session and live interaction session with the speaker at the end of the talk, in which participants having any queries can unmute their microphone and ask queries during the last 10 minutes of question answer session. They can also post their queries in the chat box if they desire so. I will take their questions with the today's speaker. Also, feedback link will be posted in the chat box only. So I request Mr. Ankit Kumar sir to start the session. Over to you, sir.
Yeah, thanks, sir.
Yeah.
Thanks for the invitations and for this FDP. And from last several months we are talking. Okay, yeah. So once again, welcome you all for this FDP. Okay, and very good evening to all. Okay, so let us start. Before taking my sessions, as sir already mentioned, if you have any doubt, any questions, we will ready to take the questions at the end. Okay, so yeah, so I will sharing my screen and then we will proceed. Hope so my screen is visible and I'm audible.
Yes, you are audible, sir. Yes, your screen is also visible now.
Yeah, yeah. Thank you. Thank you, sir. So yeah, so yesterday on the same topic, yeah. So my colleague is already elaborated solar power PV system modeling and analysis. Okay, so in that continues in that continuation, I will move ahead. Okay, some advanced topic how we can do the solar PV system modeling beyond the regular modeling systems. Okay, so I hope so, and the faculty members and those who are joined participants find this my session useful and how we can use the tools for your research projects and teaching learning methods in the renewable fields. Okay, as I mentioned, the solar PV system modeling and analysis as a topic. Okay, so in the same continuation, yeah, yeah, in the same continuations, I will be move ahead. Here, if we saw it, the Simscape is there and MATLAB and Simulink is the base. Okay, so we move in these directions. Okay, so yeah, so what exactly we are going to do? So the tools are the important. Yeah, system is a renewable, but the tools which we are going to use for the implementation, that is a really important. So MathWorks, as I think all of you have very well familiar the MathWorks tools. Okay, so you have a programming environment that is called MATLAB, and you have a Simulink where you have the block diagram environments. So with the help of this MATLAB and Simulink, how we can model the PV arrays, okay, and then other things. Okay, so we are using it in the power system, in the solar power modeling. Okay, so these two tools are using very extensively. Okay, so MathWorks helping you to accelerating the piece of engineering science with these two tools. Okay, and other additional toolboxes which is required as per our applications. Okay, so fine. So what is my today agenda? So today's agenda is a recap the previous day physics-based VB modeling. Okay, where my colleague has explained. Okay, in the same continuation, I will be move ahead. Okay, and then I will surely tell about the what are the analytical PV models, real PV data analysis, and data-driven PV modeling. Okay, and the validations with the Simulink. Okay, so these are the my agenda, or we can say that these are my talking point of the today's sessions. Okay, so let us see what is my our conventional PV systems. So all of you may well aware of the this PV diagram, PV systems. Okay, so solar PV system, yeah, we have a catching in the PV panels, and then sun is a source of energy. Okay, then we have a yeah, of course it's a DC power. Then controllers are there. Then power inverters. We have to invert it. Okay, and then the as mostly we are the AC power users, then it will be converted to the AC power, then the with the help of smart meters or grid, or maybe the for the residential purposes, okay, or the commercial loads. Okay, so and then of course when the emergency, when the excess power is there or some, and then we have to store in the battery storage as well. Okay, so this is a complete cycle where you have to connect to the grid as well as to the just a simple single line diagram. We can say that in the form of the different figures I have shown here. So major challenges today we are talking about the PV panels, solar modeling. So all this part will come. Okay, to capture to capture all these things within the seconds, we require the OD, ordinary differential equations, and then the different solvers are required. Okay, to capture the simulations. Okay, because we have a time, and then fractional of time, we are running the simulations within the 5 seconds or 12 seconds. Okay, so that is a point we have keep in mind. So this is a single diagram directed us that the Simulink, which is a tool, MathWorks tools, has a various model descriptions. Like a domains in the Simulink have a continuous time models you may become across. Then you may become across the discrete time models, physical models, state machines, and discrete event models. Okay, so when you have a system dynamics, then continuous time models will workable. Discrete time, when you have a digital control or something with a frequency analysis we have to do, then discrete time models will come into the picture. Then you have a physical models, okay, where multi-body, multi-physics systems are involved. Okay, the power system, fluid, multi-body, electronics. Then state machines, control logic, mode logics are there, where you have to make a loop applications. Okay, and then you have a discrete event models. Okay, queues architectures. Generally we come across these domains in the Simulink. As I early mentioned that I will focus on the Simulink tools today, so that how these Simulink tools are useful for the renewable energy applications. Okay, my prime goal is this one. Of course solar is a point of discussion, but let us see that. So you have to understand the different models. Okay, so whether you are working the continuous time models, discrete time models, physical model, state machine model. So accordingly, in the Simulink, you have a this type of the time frame. Okay, hope so. In these slides, you have a time frame. So because if you have a solar data, then you have to simulate the 365 days. Maybe the maybe the whole historical data may be there, and within the 10 second you want to simulate, or maybe the 60 seconds. Okay, so you have a different types of the occurrence will be take place in the renewable energy system. Okay, like a fixed step solvers we have when we have analysis within the second or milliseconds. Okay, then if you go above, then you have a variable step solvers are available when you have to solve in a year time frame from the second. Okay, so then you have a variable step solvers. When you have a minutes to milliseconds to minute, then you have a discrete type of the solvers. When your analysis falls under the couple of the seconds and the couple of the minutes, then you have a continuous simulation models. Now last which is come, that is a phasor model, where you have a very long time, means year that we are using the phasor time period models. Okay, so these things are the really important in the simulations to capturing the events, like a power system transients analysis. When you have to do, then you have to use the fixed step solvers. When you work on the fault studies, at that time you have to use the discrete events. Then power electronics, then the other thing is stability studies, then you have to use the continuous solvers. Then when you move towards the microgrids, then you have to or power quality, then you have to use the phasor or the variable step solvers. Okay, depending upon the whole system. Okay, so these are the different types of the solvers are present. While demonstrations I will show you. Okay, so these solvers we have to keep in mind. Okay, so in the renewable, these solvers has played the greater role to get the required results. Okay, now see here in the next slides, I have a model utility grid. Okay, so here I have used the utility grid. It's a 120 kV substations. Okay, and then the transmission lines are there, and there's a grounding transformers and other things are there. Okay, so localized power distribution grid that includes synchronous and asynchronous machines. Okay, so transmissions line dynamics, variety of the specialized fax devices are come into the pictures. Okay, so you have to switch between the discrete simulation type or phasor simulation type for the steady state analysis. Okay, so that's why this phasor understanding is the really important. Okay, most of the times we directly jump to the modeling of the systems, but these things are the miss. So once we have this type of the different solvers, continuous and phasors, then it is a really good for us. Okay, so now see here solar PV system with the grid integration, how it is modelings will be look like this. Okay, so now we have I'm in this model, I'm using the specialized power system toolbox. Okay, so where I have a PV array, so I simply go in the simulating, and then I will just take the irradiance and temperature level. And irradiance can be defined watt per meter square depending upon the your by the signal builder you can do, or temperature you can fix with the 25 or 30 degrees centigrades. Okay, and then after that you have a yes, you have a DC-DC buck converters that control the DC power, then regulated DC power if you require, then the DC-DC buck converters you can use it. Okay, so that models are available. And then after that, if you require the AC power, then it will be through the transmission line that will be converted to the AC power, and then it will connect it to the different feeders lines or utility grid. So this is a general Simulink model which we are using in our study. Okay, so I think all of you know where PMPP 2488 watt per 1000 watt meter per square, then others, so we can find out the maximum tracking point. Okay, so this is a simple solar PV system simulation, or we can say modeling in the Simulink. Okay, so yeah, so this is the how the typical grid connected solar PV power systems are look like. What are the different blocks we are use it. Okay, so yeah, so here we are using the specialized power system toolbox. Okay, and then the things are connected, and then we will get the results. Okay, so this is the normal way of the our regular traditional way of doing these integrations and understanding the PV systems. Okay, but today I want to emphasize on the different aspects of the modeling. Okay, so different aspects of the modeling and how I am going to do. Yeah, let's decide it. Okay, let us understand. So this is a traditional way we are doing it, but now I will bring the different modeling approaches are available in the MATLAB or Simulink. Okay, so first principle modeling and second one is a data driven modeling. Who may be come across it. Okay, we have a different types of the datas are available, historical datas are available. Okay, the first principle modeling that my colleagues has already explained about that. Okay, so first principle modeling approach where the mathematical equations are present. Okay, and then second approach is the data driven modeling. Under data driven modeling, we can utilize the plant data or rooftop data. If you just consider your home rooftop data, then also very useful for the modeling of data. And from the model, we can analyze further. Okay, so this is a two basic way. So we are doing, and to do so, we require some tools. Okay, so Simulink is there. MATLAB, of course, is a skeleton of the whole the toolboxes. Okay, so MATLAB, where you can do the programming, then you have a Simulink. Okay, then what do you have? You have a simscape where physical modeling system come into the picture, because the renewable have a equations. It has a data. It has a thermal analysis also. It has some others analysis. When you have a multi-physics, when you have a multi-physics analysis, then the simscape is recommended. When you have a simple mathematical equations, then you go for the Simulink. Okay, when you do not have any equation, only the thing is that the system identification toolbox, where you have a data, then you have to find out the transfer functions, and then you have to do the modeling. Then you might be have used the system identification toolbox. And the last, which is a very emerging nowadays, very emerging, where we can leverage the AI power, that is a statistics and machine learning. So we can leverage this statistics and machine learning for the data driven modeling. Okay, so this is the tools for modeling a dynamic system. Okay, so now see here, and further you require the Simulink design optimization to optimize all this performance. Okay, so these are the different approaches, the first principle modeling approach and data driven modeling approach, and what are the different tools are required to do so. Okay, so I think I'm clear. I'm making a two-way modeling. So now see here, so different approaches for the modeling of the dynamic system. You have a first principle modeling and second one the data driven modeling. So under that, I have just now have mentioned programming block diagram, that is a Simulink. Then you have a, if the equation does not exist in the Simulink library, then you have to modeling by the languages or symbolic methods. Okay, then you have a physical networks like that I have told you, Simscape. Okay, and then after that, once the that in the data driven side modeling, you have a statistical methods, system identifications, neural networks. Okay, CNN, ANN, likewise. Okay, so these are the different tools which are present in the MATLAB. Okay, and then after that you have to tune the parameters to get the desired results. Okay, so to do so further, you require the different toolboxes in the MATLAB. These are the toolboxes are available for the simple programming. You have a MATLAB, then the block diagram, you have a Simulink, and then modeling language and a Simscape language is there if certain blocks are not available. In a symbolic method and symbolic math toolbox is available, and other things are available. Okay, fine. And the neural and neural network toolbox, statistical method and model-based calibration toolbox, system identification toolbox are available. Okay, fine. So these are the approaches and these are the tools available with you. Okay, now see here, in the traditional methods, okay, the first principle where the equations are available. So by use of the if I go to the Simulink library browser, and then if I go the commonly used blocks, okay, in the Simulink. Then these are the things are available. Photovoltaic cell Simulink equations, where you have the gain equations are the, this is the standard equations. Okay, so we have to simply write these equations in the form of these blocks, okay, which are available in Simulink library browsers. So that is called first principle approach. Okay, so here the equation must be available. Okay, this is a traditional approach. Okay, so in this traditional approach, sometime equation not available, but is a validation and all the things come into the picture. But what is the next step with the physical component? Okay, here you do not have a worry to write down the equations. Here already you have a solar cells. Already solar cells is there. In that you have a various parameters are available. Okay, then you have a ammeter, voltmeter, and all you have connected in the in the very systematic way. Okay, so that is a physical component are available already in the Simscape. Simscape. Okay, the Simscape is a physical environment, whether the Simlink is a first principle environment. And then Simscape Electrical, that is also advanced library. Okay, so this is the three things I want to bring in front of you, all my participants, so that the in the Simscape library you do not need to make a equivalent circuit of the PV systems. Okay, already solar cells are there. Okay, you have to just bring the solar cells, pass the irradiance value, and then temperatures and other things you can set, then connect to the current sensors, and then the voltage sensors, and the again VI and PV characteristics and other things we can do. So this is the three way of the same modeling. These are different approaches. Okay, so which model you have to check? You may be asked, the questions maybe arises in your mind that the whether we should go for the Simulink approach, whether we have to go for the Simscape approach, whether we have to go for the Simscape electrical approach. Okay, so answer is within the modeling approaches. It means that if your design is required the less fidelity design, if your design is a less fidelity, then you can work with the Simulink itself. That is more than enough. Okay, but your design is required the more fidelity. Okay, more fidelity design. Then of course you go for the Simscape electrical, because here the system level design is a less. We have to focus on the overall system. Okay, you have to focus on the overall system. Okay, let us suppose you have a MPPT algorithms is there and it is connected to the grid also. Okay, so at that time you cannot pay more attention to the just photovoltaic cells characteristics. You have to work for the other parameter also. Okay, so at that time Simscape electrical play the greater role. Okay, to the model the PV systems. Okay, so this is the way I want to highlight these three tools, and I hope so I have clearly make a distinguish between these three, when to use and then how to use and what are the difference between these. Okay, now come. So here I talk about advanced library. So more things we will do. So under the advanced library, you have a Simscape, we can say the modeling and simulation environment for multi-domain physical systems. Okay, so and the foundation library is a Simscape, and top of that you have a Simscape electrical, Simscape battery, fluids, multi-body, and driveline. That is the add-ons libraries, and this will be plugged to the our regular MATLAB Simulink and other toolboxes. Okay, so this is the complete picture of the Simscape. Hope so I'm clear here. Okay, so this is a multi-domain physical system. Okay, so here I have explained through the simple photo cell or photovoltaic cell characteristics of the equations, and here I have make what are the other things are available that we can use it. Okay, in the Simscape you have an electrical system itself, it is available, mechanical, magnetic, and thermal, and other things are available. Now see here. So today's agenda, so so this is about the tools we are going to use it. Okay, so now come to the modernization of the focus area of the grid modernization and digitalizations. Okay, in the solar area, in the solar system, you have a grid integration is the major issue. Then you have a grid analytics. You have to do the grid analytics and monitoring and control. Okay, so today we will be focus on the grid analytics. That is the important part in the solar cell modeling system. Okay, so in the any microgrid operation or the things, these three things are major issue. How to connect to grid integration, how to grid analytics and monitoring and control. Okay, this is a typical. I have taken this through the geo analytics. Okay, so you have a different types of the sources, the wind, solar, generator, then you have a transmissions lines, then you have a some measurements units, then you have a switches and the substation to step down the value of the voltage which is coming through the transmissions lines. Then you have a different distribution system through the feeder lines. Okay, so this is the how this utility industry value chain system will look like. Then you have a residential loads, okay, smart, and then the plug to vehicle or vehicle to that things do you have in the system. Okay, so so in the power system or renewable energy, you have a grid integration, grid analytics, and monitoring and control. Under the grid analytics, you have to so here grid integration, microgrids, compliance, and grid power quality system will come into the picture. Under the grid analytics, you have a energy and price forecasting, where my whole session will be based. Okay, so here you can see here energy and price forecasting, maximize the value of your data using the AI solutions. Okay, so this is the whole idea behind that. Okay, and then after that, the monitoring and control, maybe through the hardware in loop or this SCADA system, you can monitor or you can deploy the things on the cloud deployment likewise. Okay, so grid analytics is a very important, where we have to forecast the things. Okay, so hope so you have understood what is the area. Now see here, under the grid analytics, you have a plant model, validations, parameter calibrations using PMU, renewables DER integrations, design simulated electrical machine control system, and other IEEE 1547 appliance, which is highly complicated. Okay, so compliance with the major field data, design the controller and protection system with the grid codes. Okay, so but sometimes what happen, you have to build a digital twins of your physical assets. Okay, when once you do not have enough data, then you have to make a digital twins in the Swimlink environment and do the further analysis. Okay, so these are the some perform the techno-economic feasibility and compliance studies of your solar grid systems. Okay, so now see here, so we will quickly jump to the MATLAB. So let us jump to the our first agenda and see that what are the things we can do. Okay, in the MATLAB. Okay, hope so. Yeah. Yes. You now see here. Yeah. So this is a window where we are talking about. Okay, MATLAB. Okay. So here I have some data. So we have to do the data-driven modeling. Under the data-driven modeling, you have various things are available. Okay, so let us see that. First of all, pass a VER command to see that. Anyone have any questions? Yeah. So now see here, this is the which tools I have talk about. Yes, everyone. So this is the Simscape electrical, which I am talking about. Here you have a Simscape. Okay, then of course here you have a MATLAB, Simulink. All the things are here. Okay, so here most of the things can be done with the Simscape electrical over here, which just now I have talked about for the data driven modeling. Okay, then simply pass a command CLC. Okay, so to get to know the different parameters. Okay, so just check whether these tools are available or not. That's all. Okay, so that purpose is there. Everybody knows it looks like MATLAB. I'm using the 25A. Okay, so here you have a home tab and here you have a Simulink. Okay, so yeah, let us jump to the my MLX file which I have prepared, or you directly go through the PDF file as well. So I already open. Okay, so this is the solar PV modeling system. So as I mentioned that the you have a data. This is the ISC data. This is the I make this MLX file. Okay, solar PV system modeling. So this is the equations I have made. Okay, this is the standard equations. Okay, then after that, and then I have defined some different parameters: IISC, I0, exponential, QV, NKT, and this is the our standard VI characteristics equations. Okay, so yeah, so I have defined the short circuit current in the programmatical way I am doing, and then after that I have defined the diode identity factors, elementary charges, then voltage man constant, all the things. Okay, so very systematic way we can do. Now see here what happened. And then after that you have to plot these characteristics. Okay, so here I have used this current equation and simply power V into I, and now I am able to plot the current versus voltage as well as power. So you see here the characteristics of the solar curve has been plotted here by using the first principle approach. Okay. Now here in the so here just I simply it's just a simple file, and I have just written the equations over here and then I have plotted. Okay. The same thing in the equivalent circuit model using the physical modeling. Now my approach has been changed. Okay. Now my approach has been changed. Now from the just simply writing this equation which I have written here, which is just simply writing the equations. So, is there any questions? Okay, fine. Okay, now see here in the equivalent circuit model using the modeling. So this is the equation. So I have used the diode here, then resistor, then this is the voltage sensors. Okay, sorry, current sensor, then current sensor here, again voltage sensor here. The variable current ramp signal I have taken, short circuit current and series resistance I have added in the series. Okay, with the help of a scope, I'm visualizing my results. Okay, so this is it looks like this. Okay, so so this is it's a power. Okay, so I have plotted this. If you I have already run this model and taken the screenshot to explain this part. Okay, otherwise it will take a long time. Now after that, as we know that we have a concept of the MPPT. So solar power power point tracking. Okay, so that the we will get the maximum output from the solar cells. So there is a various methods are available. Okay, p-turb and observe method, incremental conductance methods. Okay, so these are the methods are available. So let us see some of the methods. Now see here. So I make of this MLX file. How you can make it? So let us explore first. So if you just simply click on the live scripts, or simply type so you can generate different things. Okay, like a TT. As you know that you can use this is a very illustrative manner of writing a code. Okay, so live script, The code has been run. The things which I am talking about the last several here. Yeah, just see here. This is the solar cells. Okay, and this is the yeah, this is the equivalent circuit model. Okay, and this is my equations. Okay, so if we click here the solar cells, so this is the, I have used the port here, Tata Power solar cells. You can change it. Okay. If you need the thermal analysis, so just show the thermal port as well. Okay. If you need the analysis of the, what are the different SCR and other things are it's connected. So that analysis we can do. Here you have a thermal port and the other things are there. And there are various methods are there. Equivalent circuit, 5 parameters, 8 parameters, and out voltage, so other things we can do. So it means that in the simscape electrical, the lots of things we can do. Okay, temperature dependency, and we can define in the degree centigrade, whether we cannot define in the equation based model. Okay, so it's a much easier and much useful way you can run the model. Okay, so where it is available, so just go to the library browser. Under the library browser, here you have these tools. Hope so you have used it in your, yeah, in your research. So if you go here you have a simscape. Okay, so under the simscape, and here you have a simulink. Okay, so yeah, either simulink, and these are the tools, and then you have a simscape. Here you have a foundation library, and then you have electrical. Okay, so these are the tools we have to pay attention. Under the foundation library, also you have a electrical systems. So here we have make it from here where my cursor is there. That model I have made from the Simscape electrical, where I have connected the different yeah, elements. So if you click here, then you have electrical elements. Here various electrical elements are available. So from here you can make a circuits which I have made here. And if you go to the Simscape electrical, then the additional components are available, communications, sorry, control, BLDC and other things are available, converters and other details are there. Okay, so this is the way you can access the different components, okay, in the respective library. Okay, fine. Okay, so now this is time. Till now you have any questions, so ask, and I have explained this data sheet also. If you just simply click Tata Power Solar, so you'll get the data sheet directly. Yeah, so just see here, these are the different types of, this is a very important part. So parameterization of the different models. Okay, so here you have a, yeah, so manufacturer, collection ID, port number, part sheet, all the things, website, and here is the parameters. Different parameters are there. Okay, so yeah, manufacturer, different manufacturers, and there crystalline or monocrystalline or silicon and the other polycrystalline, all the things are there. Okay, so here you can select according to your specification. If you go here, then you have different types of the manufacturers. Okay, Honeywell, and then REC, Tata Power Solar, the Trina, and the GCL, First Solar. They have already given to you, and that solar cell you can use it. Okay, and then different formats, mechanisms are there, so that you can use it. Okay, but here it is not there. Here you have make equations. Okay, that is a difference. Okay, so this is the difference between these two. Hope so I am able to clear my point. Now come to the model, then again come to the this one. Okay, so fine, there is no need, I think so. All of you know these files. Okay, so now yeah, so to make a to Next, we will look at the MPPT. So MPPT is a sophisticated electronics, means maximize the energy harvested from the solar panel by adjusting the electrical operating point. Okay, so yeah, of course, all of you might be know that various methods are there. So as the irradiance is increasing, the PV power output have to maintain that points. Okay, so we have a two system, P and O system and incremental conductance system. So I have make this flow chart over here. I have added here. Okay, and then I make this two methods in the drop down menu in incremental conductance method. So you can see here, this is the I have used the state machines concept rather than writing a code concept. Okay, so this is the new, might be you know that the how to use this. This is also tools are available in the sim events. Okay, so here I have used the chart. Okay, then I have to simply write down the equation entry data b uh, power p previous power means current and then previous current and d minus d, and then after that I make a different nodes. Okay, so increment the duty and decrement the duty concepts and then return the value. Okay, and then after that logically I have connected according to that flow chart. So when then how the incremental conductance methods will work. Okay, so this is the way you can use the incremental conductance method rather than going for the traditional methods. Go to the .m file, create a functions. Likewise, rather than that, you can use the state flow system. Okay, so this is the way we can incorporate these things in our research. Okay, so here I have taken the screenshot and the various MPPT using this state flow I have implemented. Okay, or simply if you run this, so here buck boost converter and ideal things I have selected. Okay, that I will come later on. So now just click to the PNO method. Okay, and see that the which one has a greater accuracy. Then here I have used the MATLAB functions. Okay, so in this method, uh, voltage and current. Okay, so yeah, so we I have defined here different. If is empty, then the other parameters I have defined. Then I initialize the algorithm parameter delta, and then after that I have calculated the power. Okay, and then in this way I have increases and decreases the duty cycle based on the different conditions. So here this is the important thing, the delta I have done, and then I have if the this value is greater than 0, then this will happen, and then update the value like this. Okay, so this is a very simple algorithm which I have written, P and O algorithms to for the maximum point tracking. Okay, so this is the way we can use it. Okay, fine. So, but here you might be know this is a state flow is a new concept. Okay, so rather than writing the flow, then you can simply write the things in the state flow. Okay, so just see here. Next thing. So this is the our traditional methods. We are modeling our system in the Simulink from the last several yeah. So now see here. Here I have taken the solar cells, emitter AS6M 320 watt. Okay, here irradiance level constant value I have taken. Okay, so here with the multiplication of 200, 0, 1, 2, 3, and then I have multiplied by 2000. So variable irradiance is there. The solar cells I have taken. Then MPPT algorithm just now, which I have mentioned here. Okay, so that same thing I have implemented here. Okay, the same concept. Okay, then after that I have defined with the constant value over here. Okay, make the simple. So enabler, these are signals I have taken, and then after that duty cycles given to the DC-DC converter. So buck boost converter, the duty cycles. Then ideal, we require inverters. So here connect the DC to AC converter I have chosen. Okay, and then I have applied this concept, and then I have done this. Okay, then here you have a volt controlled current source and voltage current source. Okay, so this is the system I have implemented, and then you from here you can power tracking concepts is there. Okay, so you can simply run for the. So once the visualization will appear, so this is a simple MPPT algorithm where I have shown in different methods. Okay, through the straight line concept, and through the others way. Now see here, as the voltage has been increased, current is degraded, and the power we are seeing here. So power is nearly reaching to the maximum value, and then as the current reduces, then it will gradually decreasing the value. Okay, so voltage is picking up, then current gradually increases, and then power is also decreasing after after attending the maximum power. Okay, so this is the analysis that I have done in my study. Hope so all of you have to understand this algorithm. Now, after that, I think hope so the concept is clear. Okay, that I have mentioned here. Okay, so this is the small introduction of the solar PV system modeling, where we have to cell equations, physical modeling, MPPT, where we have learned these two concepts, PNO and the inconductance methods. So I'm using the .mlx files, and then I'm implementing over here. Okay, where the buck boost converter and ideal DC to AC inverter I have used, and then I have performed this side. Okay, from the DC side as well as on the AC side both. Okay, and then I'm maintaining the irradiance value. Okay, so as you may observe here, output power is increasing as the irradiance value getting increases, and I'm maintaining the solar cell power curve. Okay, so this is the small demonstrations about how these MATLAB Simulink tools and the Simscapes are utilized for a different type of the modeling. Now, what exactly the data-driven modeling? Okay, so this is the traditional way we are doing. So for the data-driven modeling, okay, so I have a one data with me. Okay, so I want to show the data-driven. So come to the, because there is a lots of problems are there. Okay, so yeah, so if you look at the just a minute. Okay, so now if you look at the data driven modeling, then we have apps. Different apps are available. So if you just go to the app, and then you have a regression learner app. Okay, so first of all, see the data. So I have a just synthetically generated data with the digital twins method. Okay, so open outside the MATLAB. So this is the data I have created. Okay, for the one day only. Okay, so 0, and then I equally fabricated 10, 20, 30, 40 irradiance is the synthetic data. Okay, so plant now 1430. It means that much seconds I have taken, and then these four variables: irradiance, temperature, voltage, current, and power. Okay, so now these things can be incorporated in the MATLAB. Okay, so how to do that? So for that purpose, just go to the MATLAB here. Okay, and then simply you can do this further analysis like read the table. Okay, so data dot properties variables name you can do. Otherwise, you can go to the home and go to the import the data. So simply import a data. So simply if you click here import a data, so you can directly import a data. Okay, just now the data which I have shown. Now see here. So this is the same data which just now I have shown to you. It is available with me. Okay. So if you are happy, then here you have a different types of things. Timetable, column vectors, numeric matrix, string array, cell array, all the things we can do. So just take a table here and click on the importer sections. Just click here, importer data. You can generate the live script, you can generate the live functions and all the things. Simply click on it. Okay. And okay. Okay, now see here, advanced 144 by 6 tables. This is tables is created. Now go to the plot, the different types of the plots we can plot, like a parallel plots. We can do that. Okay, so yeah, okay, so this is the way. So in the data driven modeling, so let us jump to here. If you go to the home tab, then go to the app and then go to the machine learning and deep learning section. So you have a regression learner app or some you have a classification learner app. Okay, if you have a regression learner app, so data driven modeling about the AI. Okay, so just quickly, I will emphasize what exactly AI and the thing is there. What are the things we can do within the MATLAB? Okay, so just see here. This is the regression learner app. Once you open, because the output power we have to predict. Okay, so go to the new session. Okay, and then from the file, uh, how the data driven model will helpful for us. So directly from the file we can do or from the workspace we can do, both the we can do. Take the from the workspace, select the input data. The various things are there, so select data is there already. Okay, so these all values has come which I have generated synthetically. You may generate through the digital twins and other way. Okay, so cross validation I have kept 5, and then I will click on the start the session. Okay, as data set is very small, it's just for the one day. Just I want to show you that how to do the data driven modeling and how the what are the different offerings of the MathWorks. Okay, so if you see here, so if you see here in the data-driven modeling, you first with at the regression learner. Understand, you may find out the various inbuilt models are available. Okay, like a linear support vector machine. Then you have a assembler trees, natural networks. Okay, then you have a linear regression models, linear. Then you have a stepwise linear, all linears. Then regression trees models are there likewise. Okay, so it's better to click on the quick to train. If you just click on the quick to train, okay, and then here you have to click train selected. Now MATLAB will open the parallel pool. Okay, when you have a data set, so parallelly, virtually, it will divide the uh, your data set in the different cores. Okay, if my machine is a single core, then it will do for the multiple cores. Now see here. Yeah, so just see here my RMSE value 11.4.886. So this is a predicted and then errors. So if I click on the errors, it will also show the errors. Okay, if I click this one, so this is the error somehow, and this is the predicted value, and these are the true values. Okay, so response power versus record numbers. Okay, so this RMSE value is 11.9. First of all, so still the values are very, very far away. Okay, so this is a linear regression. It's looking good. Okay, so response has been take place because I have, if I quick to train, if I click on the all and then I will train all, then it will train the all the systems. Okay, so it's up to you. These are the different models. So you can download in by the various way. You can download NASA website, and other things are also available. Okay. So now see here, the other models are under the queue. So total 28 models are there. Kernel, stepwise regressions. Okay. Then linear regressions models are there. Then after that you have a others Gaussian process model and SBA. Other models are available. Still under the queue. Let's the training period will be over because I have just 5 features. Okay, so this is the way you can calculate and you can analyze the data driven modeling as well. So here I have made us if you have a plant data, so then or you have if you have a synthetic data, and then you can do the same analysis in the AI models or data driven model also. You've just predicted versus actual. So let us explore first worst model. Which one is the worst model whose values are very far away? Let us suppose this one. So here you have a RMSE value, RA square value, MSE value, predicted speed, training time, and others we can do hyperparameter if you want to do, and the feature selections if you want to do, then you can do. Okay, like that. So now open the best model. Oh, sorry, worst model. First of all, open the worst model and see the predicted versus actual. So this is the totally not in the predicted mode. Okay. So now open the best model and see the predicted versus actual value. So now see here it's going very fine. Okay. So stepwise linear regression model are doing really good. Okay, so this is the how we can calculate. Then you, if you can go through the create a workspace model and the other things we can do. Okay, so if you create here, export the model, then the further analysis you can do. So train model is the that we have to, and stepwise linear regression model. So that is a perfectly fine. Under this, there are some optimizers are also available. If you have to Bison or grid search or random search optimization, that can also be, you can use it. Okay, for the predictions. So this is the way how how we can do the our grid analytics. Okay, so yeah, if you go here I have to go. Yes, this one. Okay, so this is the way you can do the analysis. So now you have trained models are available. So yeah, to simply type this, you will get a further information about your trained model. Okay, so this is a prediction function handle required 1 by 5 cells, and other things are available. Okay, so now if you have some testing data, if it is available with you, then you can test it by passing this y-fit function, train model and prediction t. Okay, so likewise, let us suppose if I have this data with me, and then I have to save these two column, let us suppose 2240, and just copy this and create a file, new file, and just simply save it, the first two data. Okay, so simply save this file, save as test. Okay, so where I have to save this PC, and then I have to save it this PC, and that this PC my data is in uh, just a minute. Yeah, this PC, and here I have a just make a test, test test. Okay, so because I have already historical data I have, so I can make a test. Okay, simply save and cross this. Okay, so now what you can do, simply copy this, Control C, and we have to bring that folder. This test data must be in the workspace. Okay, so again we have to t variable must be created. So t is there already, t some alag, yeah, some others names I have to give. So yeah, so for that I need to import that t file. Okay, test.slx file. So I go to the here imported data, under that test, opening a spreadsheet. Yeah, so this is the okay imported cross. So test, here you can see in the workspace, here you can see here test variables has been created. So simply do this test, test. Now see that what is our results. Okay, so now see here, you have a Wi-Fi 2.24 into 10 to the power 3. Okay, that is a sorry, yeah, so that now you can check it. Okay, you can check it. So 2240, 227, 2240 wattage is come. Okay, and now here you can say 2.2 approximately coming. Okay, third row, kindly check with the third row. So 2300.20, so 2300 approximately they are matching with the exact. Okay, so this is just for the demonstration purpose, that the how we can this just for the demonstration and teaching purpose. Okay, so I have used this. Fine, so this is the way, yeah, this is the way you can do the further analysis. Till now, if you have any questions, please ask.
Sir, as of now, there I don't see any questions. Maybe the participant will ask you after the session is over.
Okay, fine, fine,
It
fine. Yeah.
seems so to me.
Okay, fine, fine. Okay, so now, yeah. So similarly, other things. Sorry. So the slides. So this is the way my title. Yeah, where is my PPT? Yeah. So I have not went through the basic things. Okay, so I have just chosen this modeling. I'm changing the modeling approach. Okay, so yeah, I have used the statistics and machine learning toolbox for the prediction of the output power. Okay, based on the data. So here in the traditional approach, we are doing by this VI characteristics approaches. But the same thing can be also done by the black magic, we can say that, or we can say that the black box way, that is called data driven modeling. So this is the way. Yeah, of course there is lots of technicalities are there, and the different models are there. Every models has a different. Now what you can do after the train the model, if you want to make a app, then go to the app. Here you have to design the app. So just click on the design the app section. Let us suppose your train model is ready and you want to make a deploy on the cloud, or the make a one web app. Okay, so MATLAB, inside the MATLAB you have a MATLAB app designer. Okay, so here if you use this like a blank app, just click on the blank app. Okay, so here this interface will be open, like a axis, button, checkbox, depending upon your uh, depending upon the how you are going to customize. Let us suppose train the model. Okay, so various models are there in the machine learning. Okay, these are you can select the best, any best file. Okay, you can see in the result table. If you click on the result table, okay, so these are the result tables after training has come. Okay, so you have a tree, linear regressions, efficient linear, but you can see here which one is RMSE value. Linear regressions are doing, and others efficient linear not doing well. Okay, linear regression really going well. Okay, because RMSE values, and then neural network. Okay, so neural network also doing well. Okay, so now after that, SMSE value, R square value, RME values are there. So you can compare it, okay, and plot the results and export to the workspace and export to the files. All these things can be done very easily. Okay, so yeah, so this is the model, and then you can see the responses, and then further things are there. Compare the results and the residual and other things. So click your result table, what is the layout if you want, and all the things. Okay, fine. And then you have here feature selections. So which features I have to select and all other things. Okay, some features must be kept. So you have to do this analysis, MR analysis. You have to do then F test. Okay, like that. Likewise, so which features are the important? Okay, so features algorithms. Okay, so you have a voltage irradiance level. So okay, so it's showing the voltage and the irradiance has a the maximum F test under the MRMR test. If you click on the MRMR test, here current playing the greater role. Okay, and then the so these are the important features. Okay, so depending upon that you can select the features. Okay, as my data size is very small. Okay, so that the just for the demonstrations and the tools I have used this data. Okay, but the in the real sense you have a 365 days it is available. Okay, so in that case the thing will be the change. Okay, so yeah, then you have to do the further statistical analysis can also be done. Okay, so here features ranking algorithms we have used. So yeah, so this is called as a data driven modeling. Okay, so I want to emphasize then the with the help of first principle modeling that I have also seen, and the data driven modeling means what? Data driven modeling means leveraging the AI power. Okay, so leveraging the AI power. So yeah, so leveraging the AI power, and then of course regressions we have to do. So the data which I have used is just like a realistic SCADA data sets, and then non-ideal behavior just for the demonstrations and other things. Okay, so yeah, so input is yeah, temperature and ingredients, and output is a power. So regression and ML based. So this is the regression and ML based I have done. Okay, yeah. So this is the simple thing. Yeah. So just yeah. Then yeah. So this is the approach. So if you want to explore further under this, then if you simply go here or simply go to the, if you type simply MATLAB here. So yeah. So the further things we can explore. We want to explore further, and then you have these simulink sections, and then you have a event-based modeling section, that is a state flow, which I have used for the MMPT algorithms. Okay, and then if you come here, sorry, yeah, and then you have come over here, then you have a physical modeling section. So yeah, circuit simulations and all the things might be the other speaker maybe highlight these things. So just for the yeah, understanding purpose, you have a yeah, circuit simulation on RAM, then you have a power system simulation on RAM. These two things we can do. Okay. So these are the further analysis. You have to just simply log into your MathWorks account, and then jump after login, go to the my account part here. After login, just and then go to the here my courses. So just click over here my courses. So you are able to reach to these courses. Yeah, fine. So yeah, so then you have, I highly recommend that go for the machine learning on RAM. Okay, and at the end of the day you will get a this type of the certificate as well. Fine. Okay, so these are the things are there. Yeah, so for the future work, yeah, so again come to the back to the MATLAB. Okay, so yeah, then again you have to work on the state flow, then you have a Simlink events and all the things. Just a minute. Here you have a Simlink test, a Simlink real time, and here you have a state flow. So here you have a chart and a sequence viewer and all the things. Okay, so how I have implemented all this part. And then you can do with the signal analyzer app also. And then if you go to the modeling sections, so which I have highlighted the very important, the first of the slides. Okay, so here you have all the solvers are available. Okay, so these solvers I am talking about, and this is the type solver selection type, variable state or fixed state. Discrete is there and other things are available. Okay, fine. Okay, so this is the way you can do. So data driven modeling, which I have shown in my these slides. Okay, so yeah, and these are the results which I have observed. Uh, so what are the things I have covered so far? I have covered the modeling approaches. Okay, so simple equation based approach, simscape based approach. Okay, physical model based approach, and then after that I have a 1 day data of the solar power generation. Okay, and then I have used the AI, that is a data driven modeling. Okay, so I just simply for the, and then I start learning the machine learning, and then I have the regression learner app, and where I have shown how to train the model, and then what are the different training results, and then the predicted versus actual value, how to calculate, then result the table, and then how to test or validate your model. Okay, so from the you can yeah, so from you validate the model, which just now I have shown here, and I'm getting these results. Okay. Yes, any, yeah. Hope so. And then after that, I have explained the app also. So you can bring these things over here, design the app, get more app and install the different apps. So if you just click here and then different things, just click here, date and time, and then axis, you have to incorporate the axis and change these values. Okay. So you can make your own app. Okay, so design view and code view. If you go to the code view and then certain changes are required, this is a ready-made templates are available. Okay, then go to the design view and then the according to that you can make your here drop down menu you can make where just pick and drag and the different option. Now let us suppose yeah, so drop down menu. So these are the options are available. So if you want to train the model for the others models as well, okay. If we just see here, if I select the top 5 model, it's 11.86, then others models are doing also very well, like a stepwise linear regression model. Okay, so that if you want to add that model over here, then simply go to the app and then here you can change the value here stepwise regression model and other things we can do, and you can make a user interface. Okay, so this is the way you can do that. Fine. So MATLAB app is highly useful in such type of the applications. Fine. Yeah, so I'm at the end of my session. Okay, so this is the slides which we have prepared: curriculum, path, production, transmission, distribution, renewables. So this is the way: simulation based testing, the green planning, optimization, microgrid design, energy management system, and the things we can do. Okay, so MATLAB on RAM, simulating fundamental, simulating model based design, modeling of physical system, modeling electrical power system, simscape, and then optimization technique in the MATLAB likewise. So this is the way you can incorporate in the curriculum as well. Okay, so as the this is the FDP and the most of the faculties members are there. So how we can use this renewable curriculum into the your regular curriculum. So this is the way you can do. You can start with the MATLAB on RAM, then simulating fundamental, and then go for the physical system in the Simscape, then modeling of electrical power systems. Likewise, then simulation based testing and simulating, then HIL, SIL you can do, then state flow, then reinforcement learning, then the power electronics and other things are there. And then these are the different buckets, we can say that. Okay, so this is the way. So yeah, so in the basic AI approach, yeah, so this is the way. So this is the way we have discussed so far. So yeah, need computational breadth like a parameter estimation, optimization, physical and control system. Okay, then IoT and big data analytics and AI and machine learning. Okay, so I have used here parallel computing tools as well. AI and machine learning I have used, and data analytics somehow I have implemented, and physical and control system I have tool. These are the all other computational tools are required in the renewable study, and this is the summary. Okay, so when you have a utility energy industry, data integration, AI modeling, and system design and deployment. Okay, so deployment, as I told, that you can make a web app, or you can deploy on the cloud, or make a some deploy on the other things. So data start with the data integrations, access the data from the sensors, okay, and then the AI modeling, and then the system design. So these 4 steps are there in the MATLAB. We have a complete setup, end-to-end integrations we can do. So starting with power system studies, grid analytics, and cloud and real-time simulations. So somehow I have tried to touch grid analytics part. Okay, so yeah, so this is the things we have to do. Sorry, sorry. Yeah, so that is the things. Thanks. Uh, so I'm ready to take a questions if you have anyone has raised these questions. So yeah,
So participants are requested to unmute their microphone and can interact with the speaker directly if they have any query, because so far there was no specific query in the chat box. However, as I already have announced, they can unmute and interact with the speaker directly. So please, participants, you can ask your queries. You can unmute your microphone. Okay. Sir, hello. Does anyone want to ask any particular query? They can unmute microphone. Okay. So it seems the participant have understood the talk, and at present they don't have any query. Although I will request you to share your contact number and email with
Yes,
us, so that we can post it no for the information of the
yes, yes,
participants, so that if in case they realize any questions or they have any query later, at least they can get in touch with you. So thank you, sir, for your insightful talk. More specifically, the information that you shared related to the availability and flexibility of the different modeling approaches, such as Simulink, Simscape Electrical, along with their features and specifications available to the designers and researchers working in this area. This information, coupled with few live examples, have really made the session very informative, and I'm sure the participants would certainly explore these modeling options. Now so I request Mr. Ankit sir to please share your PPTs so that we can share it with the participants, so that they can refer these PPTs later. You also requested to share your contact number and email ID with us. Maybe you can put in the chat box, so that in case any
yes, yes,
participant
yes,
want to ask any query at the later stage, they can reach out to you.
yes, yes.
So since there are no more queries, I take this opportunity to express my sincere gratitude on behalf of the management, principal, sir, and organizing team of Atal FDP of AC Patil College of Engineering. So I express my sincere appreciation to Mr. Ankit Kumar sir for conducting this session. Thank you, sir, once again. With this, now I declare the end of the session. See you all participants. Good night. The team members can post the feedback link in the chat box. Sir, is it okay if you share your contact number, email, and PPTs with us, so that we can post it for the information of the participants?
Yeah, I have posted my
Aja,
link.
Aja, already you
Sorry.
have posted. Yes, yes,
Yes,
yes,
yes. Yes, you can post it, no issue.
yes, yes. Please, thank you,
And
sir.
I share the PPT later on. Just allow
Yes,
me
yes,
to.
please. As and when you get time,
Yes, yes,
maybe
yes.
today, tomorrow, you can
Uh,
do that. We have no email IDs, contact numbers of all participants, so we'll share with
yes,
them.
yes, yes.
Thank you, sir, for accepting our
Thank you,
invitation.
everyone.
Yes.
Thank you, sir.
Yeah. See you. Bye. Good night.